Hey, back for a second video dealing with universal gravitation. In the first video, I talked about how to calculate with real numbers the force of gravity, doing the product of the two masses divided by the distance squared. So when you're dividing by a variable that's squared, you call that the inverse square law. And when you do that, you can compare variables. And so in this case, we can compare forces if mass changes, either it gets bigger or it gets smaller, or if the distance between those two objects changes. In other words, if the distance gets further or if it gets closer. So let's take a look at what I'm talking about. So in our equation from the first video, right, I'm going to go ahead and use that. So we're going to say the force of gravity is equal to G m1 m2 divided by the distance squared. So what we're going to do when we compare force of gravity in this case, we can go ahead and get rid of the constant, because if I multiplied or I calculated for the force of gravity for the original amount, but then something changes and I find for the force of gravity for the second amount, that the gravities are going to be on either side of the equal sign, so they're going to cancel each other out. So we can go ahead and get rid of that. So let's do that. And so what we end up with is something like this, where we get rid of that, and force of gravity is going to be proportional to m1, m2 over distance squared. We're just getting rid of the g, and really what we're saying is that if I make a comparison between these two and I make a comparison between these two, how is that going to turn out? Right? In previous videos that I've done, I've talked about how these are going to be proportional to each other, right? Proportional to each other, which means that if you increase either M1 or you increase mass 2 or both of them, right, an increase in the product is going to give you an increase in the force of gravity. So increasing the mass of M1 or M2 or both, right, doesn't matter. As long as one of these or both of these goes up, you're going to increase the force of gravity. They're proportional to each other. And then the other side of that is the distance. So these are inversely proportional to each other. So what that means is that if you increase the distance, if they are inversely proportional to each other, that means that the force of gravity is going to decrease. So that should make sense. The further they are away, right, increasing the distance, the further you're making those objects, the lower the force of gravity is going to be between those objects. And then the opposite of that is true. If you decrease, right, if you decrease the distance and make them closer, right, the inverse, right, if you're making distance smaller, means that force of gravity is going to increase. So the idea is this. If you increase the product of this, force of gravity goes up. If you decrease it, force of gravity will go down. For distance, if you increase the distance, because they're inversely proportional to each other, if you increase the distance, force of gravity goes down. If you decrease distance, force of gravity will go up, right? Whatever happens with distance, the opposite is going to happen with your force of gravity. So here's our equation. What we're going to look at. We're going to disregard our constant for right now. And we're going to say force of gravity is proportional to the product of the masses and inversely proportional to the distance squared. That's what this symbol means. What I just talked about with this part, where if you increase mass, you increase force. If you decrease the mass, you're going to decrease the force. And then this inversely proportional relationship that's here, that's what this symbol means. It just says that force of gravity is proportional to the product here, which means that if you increase one of these, you increase this. If you decrease one or both, you decrease this. For distance, if you decrease the distance, force of gravity goes up. If you decrease the distance, if you decrease the distance, force of gravity goes up. If you increase the distance, force of gravity goes down, right? These are opposites here. But you're squaring the distance, so it's called the inverse square law. Inverse square law. So you use this when you're comparing an original amount to a second amount. And so let's take a look at what I mean. Let's say that you have two objects. You have two objects, and let's say that there is a distance between those objects. Okay? We're going to call this M1, and we're going to call this M2. We may not know necessarily what the masses are. This is just some mass, mass 2. And we have a distance between the two. So if we were going to compare the force of gravity, we're going to say force of gravity is equal to whatever this mass is times whatever this second mass is divided by the distance squared. Okay. Now we're going to disregard G because we're going to compare this to this. Let's say that we double the mass. Let's say that we double the mass on both of these. We're going to make this 2m, 2 times this an original amount here. So if you think about it, we're increasing the mass here, and then we're going to say we're going to double the mass here. So we're going to double the mass from here. Let's say that the distance stays the same. All we're doing is changing the mass. We're increasing the mass on both ends. We're going to say that the distance stays the same. So we're going to do a comparison. We're going to say force of gravity is equal to 2m times 2m divided by the distance here. So we don't have to put our universal gravitational constant in here, which we had here, because we're doing a comparison between the two. It would be canceled out on either side here. Okay. So this m stands for the mass. All we're going to be concerned with are our coefficients, our numbers that are out in front. So what is my coefficient out in front? Here, that's a 1. It's understood to be a 1. Here, it's understood to be a 1. Here, it's understood to be a 1. My coefficient here is this 2. Coefficient here is this 2. And when you look down here at the bottom, it's understood to be a 1. So it's these coefficients that I'm going to deal with when doing this comparison. So coefficients only, I'm going to say, bring that here. So 1 times the 1 here divided by 1 squared. Notice I'm only doing the coefficients. And so whenever I do that, I'm going to do 1 times 1 divided by 1 squared is going to give me 1. So whatever the force of gravity is, this is my original amount. So 1 times whatever the original amount is just going to give you that original amount. So we're saying if we doubled the mass, how much is the force of gravity going to change? How much is it going to change? So I'm going to take this 2, the coefficient, bring it down. 2 times, I'm going to bring this coefficient down. And then I'm going to divide by 1 squared. Can't forget to bring that square. So when I do that, you're going to do 2 times 2 is 4. Divided by 1 squared is going to give you 4. So what does this 4 mean? Well, that means that if I doubled both masses, I'm going to increase my force of gravity by 4 times. So my answer is if I double both masses, I'm going to increase my force by 4 times. So whatever you found your original amount to be, let's say that whatever our numbers added up to be, let's say our numbers were, the force was 100. It was 100 newtons. Well, by doubling both masses, we're going to get that there was an increase of 4 times that amount. So instead of it being 100, when you double both masses, you would get 4 times that amount, which would give you 400 newtons. Okay. We could probably look at distance. Let's look at distance. So we're always going to compare the original amount. So we're always going to say the original amount is always going to be this, right? This. This is our original. Some mass times the second mass divided by the distance squared. let's say that we decrease the distance. So we're going to keep the masses the same. The distance between is going to be the same. So here's M1, here's M2. Let's say that we doubled the distance, so 2d from our original amount, right? Remember, we're always going from this original amount here. We're not changing mass 1, we're not changing mass 2. Instead, what we're going to do is increase the distance. We're going to say that the distance has increased. So you write your equation, force of gravity is proportional to M1, we're not changing it. M2, we're not changing it, we're keeping it the same. We are changing the distance, we're going to do 2d squared. So remember, it's the coefficients that I'm concerned with. The coefficient here is 1, it's understood to be a 1. The coefficient out in the front is understood to be a 1. The coefficient here is this 2. So the way that I write it, if I bring only the coefficients, is going to be 1. That's the first one. The second one is the 1, so 1 times 1. I'm going to bring this 2, and we can't forget to square it. So I'm going to bring the squared down part here. So it's 1 times 1 is going to give you 1. 2 squared is going to give you 4. So when you look at it, it's 1/4 the original amount. So that x is just 1/4 the amount, right? Earlier I put that it was 4 times the original amount. Here it's just 1/4 the original amount. So what that means is that if originally you had 100 newtons, if you double the distance, you're going to make the distance 1/4 what it originally was. So instead of it being 100, by doubling the distance, you're going to make it 1/4 that original amount, which is going to be 25 newtons. So by increasing the distance, you've decreased the overall force, and that should make sense because if you remember, we talked about the inverse relationship here. By increasing distance, you should see a decrease in the force of gravity, which is what you see here. We've doubled distance and we've decreased the force from the original amount here. Okay. Let's look at one more. Let's say that we keep the masses the same, M1, M2, but let's say that we half the distance. So the distance is going to be 1/2 the original amount. So what was the original amount? It was just d. So half the original amount is going to be 1/2 of d, 1/2 the distance. So let's go ahead and set up our equation. Force of gravity is M1 times M2 over the distance squared. So it's going to be 1/2 of the distance. We can't forget to square it. So we're only going to be looking at coefficients. The coefficient is understood to be a 1 here. It's understood to be a 1 for this mass here. And the coefficient is this 1/2. So let's bring those down. So I'm going to bring down the 1. It's the product of the two masses over the distance. This coefficient is a 1/2. So it's 1/2 squared. 1/2 squared. So 1 times 1, that's easy enough. That's just a 1. Now, if we're squaring a fraction, you square the top and you square the bottom. So 1 squared would just be 1, and then 2 squared would be 4. So 1/2 squared is 1/4. Now, you can't divide by a fraction here. So what you have to do is you have to flip this, take the inverse, and then multiply it. So when I flip it, it becomes 4 over 1, because this is our fraction, 1 over 4. Can't divide by a fraction, I'm going to flip it. And so when I flip it or take the inverse, it becomes 1 times 4 over 1, which is just 4. So you get 1 times 4 is going to give you 4. So it's 4 times the original amount. 4 times the original amount. So from our original thinking, we said if we increase distance, force of gravity goes down. But this time we're saying we're going to decrease distance. So decreasing distance is going to increase the force of gravity. And that's what you see here, that it increases by 4 times the original amount. So if I look and say, okay, this is my original amount, just some number that I made up, then I'm going to multiply 4 times that amount, and it's going to be 400 newtons. So by making the distance closer, making the two objects closer, I've increased the force of gravity. Okay, so these are just some examples of dealing with proportionality. Okay? There's a lot of different things that could occur. You can increase one mass, you could increase both mass, you can increase one and decrease the other, you can make the distance closer. The idea is that you're going to just follow these same ideas. You're just going to use the coefficient that's out in front. If there's nothing there, it's understood to be a 1. If there is something there, then that's the coefficient that you're going to use. And that is what you use to solve for how much you're going to increase or decrease it by. Because your answers are not the amount of force of gravity, it's how much does it change by. So you can increase it by 4 times the amount, or you can decrease it to 1/4 the original amount. So lots of different combinations that can occur. You should be able to know beforehand what's going to happen. If either one of the masses increases, force of gravity increases. If one or both of the masses decrease, force of gravity is going to decrease. If the distance increases, the force of gravity should decrease. And then if distance decreases, the force of gravity should increase. Okay? And then the last thing I'll leave you with is don't forget to bring that square down. You have to do the square. Even though you're going to bring the coefficient down, you still have to square whatever that coefficient is in front of that distance. Okay? I know that was a lot. Hopefully that helps you solve for these. Ask one of your teachers for more help if you need. This is just an intro, a gateway into how to solve for these. If you need more help, like I said, ask one of your teachers, and hopefully this helps you out. Okay.